Hey guys, welcome back. So let's go ahead and continue our journey in which we start building our machine learning model and try fitting our model. So what we did in the last lecture is we in detail saw how to define your capital X and small y, the matrix and the vector, right? So this is nothing but your input phase, right? So you basically gave your inputs and your outputs to the algorithm. Now in this lecture, we are going to precisely look at that particular portion, that the second phase of it, like how do you supply it to an algorithm, which we basically called as fitting the model, right? So essentially, there is again a simple framework that you need to follow. There are three steps to it, right? When you actually start writing some code, one is you have to import the class, second one is you have to instantiate it, and third is what we call as fitting the model. So don't worry too much. In about 2 minutes, I'll show you how to do that. And these are the three steps which we will pretty much require in any algorithm that you're trying to use. So in this, we'll be starting with the KNN or the K nearest neighbor algorithm. In the previous lecture, we talked a little bit about what that whole algorithm is about, right? How do you draw the boundaries and the neighbors and stuff like that. Now again, just to reiterate, that was a very, very oversimplified way of telling you what KNN does. Definitely, it will require a more statistical lecture to go in very much detail about what that algorithm does and so on and so forth. And what I probably was thinking is that's not a perfect fit for this particular course, because here we are just trying to get ourselves acquainted with the concept of data science, what are the components involved and so on and so forth. All right, so the way that I generally start off is, before I implement any algorithm, I would just go to the scikit-learn website and look at some documentation and sample code. So this is how it looks like, right? You just type in the KNN search and it'll give you a bunch of stuff here, right? So the class is sklearn.neighbors, and you use the neighbors classifier and you pass in a bunch of things in it, and we'll see more into that. All right, so there is good explanation on what each of those parameters do, and if we don't supply those parameters, it's going to actually use the default values, right? And here is some sample code to get started with. Now this is what I generally use, to just look at how they are importing the classes, modules, and so on and so forth, and how they are fitting in the models. But don't worry about it. I'll show you from scratch all these things. But I just wanted to let you know that this is how you should be starting when you choose another algorithm. All right. So let's go ahead and start writing some code. So this is the portion we are going to do now. All right. So I have opened my Jupyter workbook, and in the last lecture we defined capital X and small y, right? And this we are going to go ahead and fit the model. All right. So if you remember, initially what we said was that first is we have to import the class, right? And looking at the documentation, we found that to import the class, we need to use the KNeighbors classifier, right? So I'm going to use sklearn dot neighbors, and I'm going to import the KNeighbors classifier. And how did I get this? I just looked at this particular documentation, KNeighbors classifier, right? So I need to do this. So I need to import that first. And let me go ahead and press Control and Enter, and it has imported that. And next what I'm going to do is I am going to use the KNN. Actually, I need to first instantiate KNeighbors classifier, right? So I'm going to use KNeighbors classifier, and I'm going to just pass in one default value over here. The number of neighbors equal to 1. And I'm going to store this in KNN object. All right, so just keeping it very simple here, I passed in n underscore neighbors is equal to 1. And if you look at the documentation, there are actually lots and lots of parameters that you can pass, right? And all the parameters are listed here. And what we did was that we just passed one of them, right? N underscore neighbors. And if you don't pass all of them, all it'll do is it'll use the default values. Now, to keep this example very, very simple, let it take the default values, right? We'll just use the number of neighbors equal to 1 and fit the model and see how it predicts, right? The goal is again not to go into too much detail of the algorithm here, but just to look at some working code. So I'll press Control and Enter, and it gives me an error because I might have misspelled something. Okay. So that worked out fine. And now what I'm going to do is I'm just going to print this KNN object, Control Enter, and if you see that it has actually set all the default values except for n underscore neighbors equal to 1, because that is what we passed in. So these are all the values that you can set when you are instantiating the class, right? And any algorithm that you take, it'll be the same principle to be followed. There'll be a couple of default values that you can set, and then you can use it going forward. All right, I'm going to press the button B for a new cell. So now we have the instantiated class, right? Now we can go ahead and fit the model. The way we can do that is we use the KNN object that we just created, and then just call the fit method and pass in two things: our input matrix, capital X, and our output vector, small letter y or lowercase y. Once we do that, it will actually complete that next fitting the model step, right? So this is the step I'm talking about. So it will actually take an X and Y and put it into the algorithm. That is basically called as fitting the model. All right, so that is done. Now, how do I know that this all worked fine, and how do I know whether it's predicting something? And the answer is very simple. Let's try inputting some values and see whether it can predict something, right? So let's go ahead and do something. So if I use the KNN dot, and there is something called as a predict method. These are all inbuilt methods. Let me pass on some values to it. So I have some values here, 2, 4, 3, 1, right? And this is again similar to our earlier table, right? So we used to pass in values like this: 5.1, 3.5, 1.4, 0.2. These are the four input values or features. So I'm going to just use that. So I'm going to pass another 4 random values, 2, 4, 3, 1, and see what it predicts. So the way you can do is just pass in as one matrix, 2, 4, 3, 1. I can kind of do this, and whatever is the results, I can kind of store it in, say, something. You can name it anything. I'm just calling it prediction. And the value is now stored in the prediction variable that I just created. Now I'm going to just go ahead and you can actually even look at the type of prediction. So it's an ND array, so it returned an array. So when I call the predict method, it returned an array over here. And now what I'm going to do is I'm going to just print it out. Okay. So it basically returned an array, and the value is 0. Now what is 0, right? If you remember our fundamental principle of of this algorithm, we said that it should be numerical and as separate objects and numpy arrays, right? So your output is also numerical. Now what is that 0? That is what we said that when this particular table was created, We said that I dot setosa may be 0, I dot something else may be 1, and so on and so forth, right? So those are basically the target names. Now which target name corresponds to 0 is what we have to find out now. And to find that out is pretty simple, right? What I'm going to do is I'm going to just print out the target names. And if you remember, we had used target underscore names to get that out. And you see 0 is setosa, 1 would be versicolor, and 2 would be virginica, right? This is how the the array would be numbered. So in short, we fitted the model and we tried for inputs 2, 4, 3, 1, right? And the output was setosa. So let's make a note of it. So the output was 0 or setosa. So now what did we do is we used the KNN algorithm. We used n is equal to 1 in our default values. We fit the model first of all, so that it learned the existing inputs and outputs that we gave. And then based on what it learned, we said that, okay, now depending upon what you learned, can you predict what happens when the inputs are 2, 4, 3, 1? And it predicted that it is setosa, right? So congratulations, you have written your first very raw, very primitive program, right? So let's take this a step further, right? So let's say that I want to predict. So now we predicted only one input, right? One row of data. What if we need to do 2? And it's pretty simple. So the way that you can do it is again the same thing. I'm going to say store my results in prediction array, and I'm going to use the same k.predict, and my first would be 2, 4, 3, 1, and I can just keep giving more and more inputs, 4, 6, 5, 3, right? So one line of data with 2, 4, 3, 1, second line with 4, 6, 5, 3. These are the features. And let's see if it can predict something. And let's see. So it's 0 and 2. So that means it's setosa and versicolor. So when you give this input, the predicted output is 0 or setosa. And for this one, 4653, it is versicolor, or sorry, it is virginica or 2, right? So let's make a note of it. So when I have 2, this remained the same. And this became virginica, right? So I hope you're getting it. So I can kind of pass a complete matrix itself, like, and then it can actually return a complete vector of all the predictions in one shot, right? So, as and when you need to have more and more inputted data to be predicted, you can use different forms and techniques. But right now I'm just using 1 or 2 examples. In like later videos, we'll see how to kind of pass in 50 lines of inputs or 100 lines of inputs as a complete matrix, and then get the output. All right. So before we go any more further, I would like to also tell you that we used KNN equal to 1, right? So what will happen if I have to use KNN equal to 5, right? So KNN equal to 5, what will happen? We know the values of 1. So let us just copy that. And let's see if the value of, if n has changed, does the predictions change, right? Let's see. So for KNN equal to 5, I'm just going to use another object. I'll call this as KNN 5, and then I'm going to use the same thing, K neighbors classifier. And now in default value, I'm going to just pass in n underscore neighbors equal to 5. If you see above, what we did is that we used the same thing from sklearn neighbors. Oh, by the way, you have already imported the k neighbors classifier, so you don't have to import it again. but we used KNN object, and then we just use n_neighbors for k neighbors classifier. Now we are just using another one, KNN5. You can call this anything you want, but now I'm basically instantiating with n equal to 5, the number of neighbors equal to 5, right? So once that is done, I am going to use the same thing, right? I'm going to use KNN5 dot fit, and I'm going to pass in my entire capital X, entire matrix, and my output, and let it study the interactions between both of them. So it did that. And next what I'm going to do is I am going to just create a new object. Let's call this prediction 5, and I'm going to use KNN5 dot predict, and I'll use the same inputs that I passed in for my previous example, right? But my previous example was based for n equal to 1. Now here it is n equal to 5. Let's see if that makes a difference. And let me go ahead and print prediction 5. So now it is 0 and 1. Earlier it was 0 and 2, right? So now it is saying it is setosa and versicolor. So let's make a note. All right. So like, why is this happening, right? For n is equal to 1, we got some other results. For n is equal to 5, we got some other results. In the coming lectures, we will definitely see what is more correct. Right now, we don't know what is more correct, right? And let's keep it that way for now, right? Let's just, our intention is to, get some practice over fitting particular algorithms, models and stuff like that. And in the coming lectures, our goal would be to tune that, right? Given n is equal to 1, n is equal to 5, n is equal to 8, 13 or whatever numbers, or even another algorithms, right? Here we are just using KNN, right? So we use say 10 algorithms with different input variables, we will get different results. So that is where the fine tuning will come, and kind of shortlisting out of those 30 things that we saw, which is more closest to the correct answer, right? So we have reached here. We have seen n is equal to 1, two inputs and 2 predictions. N is equal to 2. N is equal to 5 and another 2 predictions for the same set of inputs. Now, what I want you guys to do is, can you repeat this for n is equal to 8 and see what results you are getting, right? So in further readings, I have given you something on k neighbors classifier, the documentation that I used, but more importantly, can you run this for n is equal to 1, 2, 3, 4, 5, 6 up till 30 and build a table? And it's actually very simple. If you see, this whole thing took me 3 lines of code. So what I want you guys to do is learn something or read about Python looping construct. How can you run this in a loop, right? And I have provided a small link which will help you get there. But basically, try doing that, and I have given you answers for n is equal to 8 over here, and it's again the same thing, right? I just use this same example, but the default value while instantiating, I just gave it as n is equal to 8, like n_neighbors equal to 8, and ran the whole stuff again, and this is the answer that I got. But try it out from 1 to 30 in a loop, in an automated loop, and see if you are able to get that. And if you are able to get that, please post it in the forum. It will be really a nice achievement, I would say, if you are an absolute starter. And the next thing is, definitely take one more algorithm. Take logistic regression. We used k nearest neighbor. Use logistic regression and try to run the same algorithm, a same set of inputs, but for different algorithm called logistic regression, right? And try to take a stab at that. I'll show you how to do that as well. But if you just type in logistic regression, you will get some documentation around it. And I showed you how I do it. This is how you can import the class, right? And this is how you pass in the default values. And try to read a little bit about that, and see how much it varies from KNN in terms of what predictions it is making. So we are getting more and more into it. Hope you're liking it. In the next lecture, we'll look at a few more things, a new algorithm, and see what type of predictions it gives us. Thank you, and see you in the next lecture.